Lesson objective for this video, students will use sine and cosine to find missing side lengths in right triangles. So prior to this, we have talked about the tangent ratio, so today we're going to talk about two more trigonometric ratios. First one is sine, which is abbreviated SIN. And so if I'm looking at angle A here, the sine of angle A would be the opposite over the hypotenuse. So opposite is right here, and the hypotenuse is always opposite the right angle. So in this particular case, the sine would be BC over AC. So if I want to find the sine ratio for a given triangle, I just have to set up the fraction of the opposite over the hypotenuse. So we're going to find the sine of angle U and the sine of angle W and write the answer as a fraction and a decimal to 4 places if necessary. So again, you'll want to look at the picture and figure out what's the opposite, what's the hypotenuse. Well, the hypotenuse is always opposite the right angle, and then for angle U, the opposite side will be 16. So the sine of U is just opposite over hypotenuse, which in this case is 16 over 34. And those are both divisible by 2. So we get 8 over 17 for the reduced fraction. And as a decimal, it would be 0.4706. And again, at this point, you're not using the sine ratio to find a side. You're just finding the sine ratio. So you're not using the sine button on your calculator. It's just a division problem, 8 divided by 17. All right, so let's take a look at angle U. Oops, that was angle U. Angle W. So the hypotenuse is still the same. And then opposite now is the 30. So the sine of W is going to be 30 over 34. And again, that can be reduced by dividing by 2. So it reduces to 15 over 17. And 15 divided by 17 is 0.8824. So now we found the sine ratios for angle U and angle W. And just like we could use the tangent to find missing sides, we can also use the sine to find missing sides. It just depends on which sides I have to work with. So example 2 says approximately how far would you walk if you were to walk diagonally across the basketball court? And they told you that the angle is 62 degrees, the length is 94, and you're trying to find the diagonal length. So the part that you're trying to find is actually the hypotenuse, and then relative to the 62-degree angle, 94 is the opposite. So since I have opposite and hypotenuse, I know I need to use the sine. So in this case, the sine of 62 is going to equal 94 over x. So if I multiply both sides by x, that'll get the x up on top. And then I can divide both sides by the sine of 62. And so if you plug 94 divided by the sine of 62 into your calculator, you should get approximately 106.5. And our units were feet, so don't forget to write your units. Again, double check that when you put this in your calculator, you get the same thing that I'm getting. All right, the next trig ratio we're going to talk about is cosine. Cosine is abbreviated COS. And again, we're going to look at angle A here. So the cosine of angle A is going to be the adjacent over the hypotenuse. So for angle A, adjacent is right next to it, touching it, and hypotenuse is opposite the right angle. So a way that we can remember all three of the trig ratios we've learned so far is with a mnemonic device, SOHCAHTOA. And so what that means is the sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So you can use this to remember the different ratios. Alright, so for example 1 on cosine, we're going to find the cosine of S and the cosine of R. So looking at angle S, 45 is adjacent, and 53 is the hypotenuse, and those are the two that I need, adjacent and hypotenuse, because the cosine of S is going to be adjacent over hypotenuse, or 45 over 53. And that can't be reduced, so we'll leave the fraction as that, and when you do 45 divided by 53, you get 0.8491. And looking at angle R, now my adjacent is 28, but the hypotenuse is the same. So the cosine of R adjacent over hypotenuse is 28 over 53, which again cannot be reduced. So just do 28 divided by 53 in your calculator, and you should get 0.5283. And just like sine and tangent, we can use cosine to find the value, the missing value in a right triangle. So here we've got x, which is our adjacent, and 12 is our hypotenuse. So because it's adjacent and hypotenuse, I know I have to use cosine. So the cosine of 52 degrees equals adjacent x over the hypotenuse 12. In this case, the x is already on top, so all I have to do is multiply both sides by 12. And so x is equal to 12 times the cosine of 52. And when you put that in your calculator, you should get approximately 7.4. Again, double check that you get the same thing that I'm getting. Alright, now we're going to find the sine and cosine of 30 degrees by using our special right triangles. So I've got a 30, 60, 90 triangle with sides of 1, 2, and root 3. So if I'm concerned with the 30-degree angle, then the opposite is 1. The root 3 is my adjacent, and 2 is the hypotenuse. And again, while you're getting comfortable doing these, it's not a bad idea to mark your triangles so you keep them all straight. So the sine of 30, sine is opposite over hypotenuse, which is 1/2, and so that's just a 0.5 when you put that in your calculator. And the cosine of 30 is adjacent over hypotenuse, which is root 3 over 2. And so when you put that into your calculator, it should come out to 0.8661. Now make sure you're careful with the calculators that you, especially if you have a two-line calculator, you're going to want to close the parentheses on the 3 or else move the arrow over so that you have the 2 isn't under the radical. So you should have something like that when you do it. Be careful. Don't leave the 2 under the radical because that will give you the wrong answer. So when you put it in your calculator, make sure that the 2 is no longer under the radical. So double check again that you get the same thing that I did, that you get a 0.8661 so you know you're using your calculator correctly. Okay, so now here's one for you to try on your own. I want you to find the sine of angle B and the cosine of angle B and give me the answer as a fraction and a decimal to 4 places. Pause the video now. Okay, so for the sine of B, you should have done 21 over 29, which comes out to 0.7241. And for the cosine of B, I had 20 over 29, which is 0.6897. Make sure you guys round properly when you're dealing with your decimals. Okay? All right, here is another one. You're going to find the lengths of A and B. So you're going to figure out which part do I need to use. Do I need to use cosine or sine? And it all depends on which 2 pieces you have. So for instance, if you have A, which is adjacent, and 10, which is the hypotenuse, so the TOA, we've got adjacent here and hypotenuse here. So which one uses the adjacent and the hypotenuse? Cosine. So to find A, you should use the cosine. Okay, go ahead and pause the video now. So for A, you would have said the cosine of 50 was A over 10, multiply by 10. A is 10 times the cosine of 50, and that comes out to 6.4. And then if you want to find B relative to the 50, that's opposite. And so we're going to use the opposite and the hypotenuse, or the sine, to figure out B. Pause the video now. So for B, you would have said the sine of 50 is B over 10, multiply both sides by 10, and so B is equal to 10 times the sine of 50, or approximately 7.7. Now this next one, I'm going to let you figure out on your own whether you're using sine, cosine, or tangent. Look at what's given to you and figure out which trig ratio applies. So you're going to find the height h of the staircase. Pause the video now. So this time you had the opposite and the hypotenuse, which is the sine. So we're going to use the sine of 28, and that equals h over 17, opposite over hypotenuse. And then we'll multiply both sides by 17 to get the h alone. So h equals 17 times the sine of 28. And when you put that in your calculator, you would get 7.98. So if it said that you needed to do it to just one decimal place, you would make it 8.0. And that concludes this video. Thank you.